Hello students, one student has answered. What about others? I don't know whether his answer is right. Okay, what is your answer?
60 degrees.
How did you get it?
So first we will apply conservation of energy between that AC position when it is vertical and when it is horizontal, sir, before breaking. And then we will get one relation for MGL, that is length of the rod if we take as L, sir. And again we will write the conservation of energy for the vertical position and till it goes to angle theta, sir. There we will get some cos theta term we will get.
Hello. See, this rod has been broken here.
Yes, sir.
What did you do with the what did you do here after it breaks? How did you account for the energy?
It is not exerting any reaction at the breaking point, sir.
So.
And also they have not given anything about A, so we will consider frictionless. That height difference which is there, no, sir. That can be accounted by the center of mass, sir. If we are taking.
That will account it for center of mass.
Yes, sir. Like when we are taking for this rod, we will be taking L by 2 distance. Center of mass will be at L by 2. Like that we will be doing, sir. Here also that way. Here now it will be at L by 4, sir. And then that height difference which we will get, sir, that will be MGL into 1 minus cos theta. Like
no, but what? See, now here you see you will write the energy equation here, right? And then when it is here also you will write the energy equation.
Yes.
And then this rod will get dislodged. That means only this rod is there, and what is the energy of the portion of the rod that is still hinged? What is did you calculate the energy of the rod which is hinged?
Yes, sir.
How much is the energy of the rod which is hinged?
Here it will be mg hinged at horizontal position, sir.
Hey, I am telling you, this rod AC is broken here at the center, no?
Yes, sir.
Then what is, see, supposing it is broken at the point B here, right?
Yes, sir.
Then
yes,
what is the energy of the rod AB?
At angle theta?
No, not at angle theta. At 90 degrees.
Sir, we will not require that, sir, so I did not calculate.
You don't require this. And then,
yes,
when it stops here,
that we will require, sir.
See, that means now, how do you know it? How will you account for the energy of this rod here? See, what is the relation between the energy of the rod here and the energy of the rod here? Because this rod, see, this rod when it got dislodged, this was also having some energy. Correct? So the energy of the rod AB, which is remaining, will be equal to the energy of the full rod, okay, minus the energy of the rod BC. Then
sir,
that remaining energy is what
you have not considered that in potential energy.
You tell me, you write the equations neatly what you have written and you send that you send that solution to me by WhatsApp.
Okay.
Because without calculating this energy, how are you able to get it here?
Not potential energy, sir. That rotational kinetic energy.
Rotational kinetic energy only.
That I have done, sir.
You write. What is the kinetic energy of the rod AB? What is the kinetic energy of the rod AB? Hello, what is the kinetic energy of the rod AB at this position? You tell me.
ml square omega square by 3 will be.
Well, what is omega?
Omega will be that this thing which it is rotating.
Okay, ml square. Then what did you write?
Omega square by 3.
By 3. No man. You are not telling the
for the whole rod it will be by 3, sir.
No.
And when we are taking the broken rod it will be by 24.
How did you get there?
Sir, by 24 because L by 2 whole square will happen, sir, because it is
no. See, you have, it is broken here. So you at this position, what is the kinetic energy of the rod? Kinetic energy of the rod AB plus kinetic energy of the rod BC. This point is B, right? Of the rod BC. So you tell me what is these two kinetic energies, Okay, then if you know the kinetic energy of AB, then okay, where it is going to stop, that is the next calculation.
Okay, sir, kinetic energy of AB when we will consider.
How much is it? How much is it?
ml square omega square by 24.
ml square
omega square by 24.
omega square by 24. How do you get this?
Sir, when the rod broke, sir, we had L by 2 length left. We know what is the moment of inertia of straight rod, sir, of length L. But now here it is L by 2 length. So ml square by 3 will become.
So 2 2s are 4, 2 2s are 4, and 4 3s are 12. And where did you get 24?
Sir, that we will get from the half I omega square.
Half I.
For rotational.
How did you tell me how you got this first? Just tell me.
That is half I omega square, sir.
Okay, half I omega square. Okay, tell me what is the I you have taken here?
ml square by 12, sir.
You have taken ml square by 12.
Yes, sir. Half into ml square by 12.
ml square by 12. Okay.
Into omega square. Yes.
You got 24.
Yes, sir.
This is the kinetic energy. This is ml square omega square 12 is what you have told is what? The kinetic energy of the entire rod AB.
Yes, sir. Yes.
I am asking you only the entire rod AC. You are told. I want only AB. I want only AB.
I have only told for ABC.
Then how it will be for AB?
Sir,
oh, hello. Gentlemen, AB mass is m by 2. AB mass is m by 2, not m. So if I go by your formula, then it should be m by m. I cannot take m here. I should take m by 2. Then I will get 48, not 24. No, gentlemen, I am sorry. See.
That mass I forgot to put it.
No. Then if you got 24 and if you are getting 16, no, it is not done. Something is not right. See, you should do it very sincerely. I am telling you. No doing goof up and all. Okay. Hello, friends. Others? Anybody? Okay. Let me give you a hint and we proceed. Hello, friends. Now, please stop solving. Look at this. Hello.
Yes, sir.
What is the energy in this position? Energy in this position will be what? Hello?
mgx.
Yes, mgl. The length of the rod is L, isn't it? So with respect to this point, it is L. This is the total energy. And at this position, what will be the energy? The energy will simply be half I of AC into omega square. Correct?
Yes, sir.
Now,
that is ml square by.
No, just keep quiet. You have already told, I have listened. Now you don't interrupt in between, unless I ask. So what is IAC? Okay, so you have got IAC square here. Now the condition is this portion of the rod breaks and without giving any reaction it comes up. Correct? This BC portion of the rod will break and come down. Correct?
Yes.
So what will remain here now is only this portion of the rod. The other portion of the rod has broken and it is falling down. So this portion of the rod, which portion? A, B, right? AB portion of the rod. I hope you got it, students. See, this portion of the rod, BC, is falling down, right? Falling down because of this one, it is going like this or something like this, not to be bothered. But this one has got some energy. What is the energy? IAB into omega. This is the energy of this. Correct?
Yes, sir.
Now, because of this energy, this rod is going to swing and keep swinging. This rod will keep swinging, and then after going to angle theta, it is going to stop. Correct?
Yes, sir.
Then here it is going to stop. So what is the potential? So that means now it stop means its kinetic energy is 0. So what will be the potential energy? This length of the rod is L by 2, and this mass of the rod is m by 2. Correct? Hello? And therefore, what will be this height? This height will be L by 2. What is this height? This height will be L by 2 into cos theta. Correct? Hello?
Sir.
Huh?
L by 2 into cos theta.
So therefore, the potential energy of this point will be m by 2 g into the height is L by 2 cos theta. Correct? That will be the energy. Hello?
Yes, sir.
Now, this energy, this kinetic energy now, see this rod was here, okay, this rod was here. Now this kinetic energy of the rod has got converted into potential energy. Correct?
1 minus cos theta.
One minute. Correct? No, Abhinav, don't answer. Please don't answer till I ask you. Please, you have solved. I'm just concentrating on others. So this kinetic energy will be equal to this. Agreed? Others?
Yes, sir. Yes.
Are you sure?
Sir.
Sir,
there will be some potential energy.
Yes, I want you to say there will be some potential energy because you are taking the reference at this point and you have written the equation, isn't it? So therefore, this kinetic energy plus what is the potential energy of this? M by 2. If you take the center of mass, this point. Hello.
Yes, sir.
G into what is the height of this from here? L by 2 plus L by 4.
Yes, sir.
L by 2 plus L by 2. This is the potential energy, correct? And this must be equal to m by 2 into G into L by 2 cos theta. Correct, students?
Yes, sir.
Yes, please.
Sir, that equation MGL equal to half IAC omega square, sir. There also we should add the potential.
Correct, Nathan. You must add. And what is the potential you are going to add here? Mg into L by 2. Because at this, see, when the rod is acant, when the rod is acant, the center of mass is this point.
Yes, correct.
Correct? Correct. See, I am. Don't think I am writing whatever I know, right? I am writing here, and I want students to be involved, and you have to tell me, okay, sir, no, sir, this is it, and this is precisely. Otherwise I would have paused and said, is this correct? Okay, because I'm sure you would have got a hint from this, because I have added the potential energy here. Then you should that at least that should trigger that we should add the potential energy here. Okay, clear, students?
Yes.
Right. So therefore now this equation. So here IAB square plus MGL I should add. Correct? Hello.
Yes.
So already you see IAB square. This one is equal to so and so. Right. Okay. Fine. Is this all clear, students? Now what we have to find out here? We need to find this theta. Right? But here you see you can find out IAB. What will be IAB? IAB will be m by 2 into L by 2, because you are going to find the moment of inertia of this portion of the rod about this point, square into 1 by 3.
Sure.
IAB you can find out. But the question is omega square. So if you are able to calculate omega square, then the problem is solved. Is that clear?
One dot, sir. So that m by 2 gl by 2 cos theta can explain, sir, the potential energy.
Man, see this rod is like this. This rod is like this. So what is the potential energy of this rod with respect to this point, this height? Isn't it?
Yes.
So what is this? What is this height? This mass of the rod is m. Oh wait, I have taken L by 2 cos theta. No, only I have taken this side. I should say 1 minus L by 2 cos theta. Hello, this height, no?
Yes, sir, that's all. 1 minus L.
Yes, yes. 1 minus L by 2 cos theta. Thank you.
Sir, L minus L by 2.
L minus L. Correct. Thank you.
Yes, yes.
Right? So now you have to just find out omega square, and then the problem is, and then if you substitute for omega square, the problem is done. Now at this stage, I want all of you to think. So I am not here to solve the problem, I want you to solve. How will you find omega square? I'm sure you should be able to find. Yes, please. Good. I like that. Okay. Now somebody told me you have got omega as what? You got omega as
root of 3g by L.
Root of 3g by L. You got this. How did you get this?
Sir, that equation mg is equal to half.
You tell me. You please keep telling. I'll write the equation. You please keep telling. I'll write the equation. Please tell me. How did you get that?
Sir, we can send that mg L by 2 on the right hand left.
Listen,
left
I am writing the equation. You tell me I am writing. Why don't you understand this? How many times should I tell you? It is for everybody in the class. You tell. I will write what you have done. Come on, tell.
So we can write half IAC omega square equal to.
You can write no. You tell me, right, sir. Half IAC
omega square equal to mg L by 2
is equal to omega square mg
L by 2.
mg L by 2.
Yes, sir. We can send that mg L by 2 term on the right side.
mg L by 2.
Send that equation mg L by 2 term is on the right side. No?
See, you should tell in such a manner that there are other friends of yours. They should also understand, man. It is not only between you and me. See, somebody will ask, how did you write that? Why don't you tell me in proper steps?
Sir, we can write that mg L
You tell clearly. Initially it is mgl, correct? Now this is equal to half IAC into omega square plus mg L by 2, correct? No, this is what you have written now.
Yes.
Then you have taken this. You tell in steps. Other friends are there. I am not. It is not only between you and me, Jugalbandi. So here you will write here half IAC omega square is equal to, you are sending this here. Now you are writing here mg L by 2. Okay, done.
Yes.
Further.
IAC is, we can substitute for IAC.
You can substitute for IAC and you will get omega square. That is precisely what you have done. Correct? Okay, fine. So you substitute for IAC here. So for IAC you are substituting it as n L square by what? IAC about A, no?
What A? By 3.
About A. Okay. Into omega square is equal to mg L by 2. Right. So m's get cancelled and 1L and this L will cancel, this 2 and this 2 will get cancelled. So I will be left with omega is equal to 3g and L by L. under. Yes, correct. Perfectly correct. Okay, now you substitute therefore omega square here and get the equation. Correct?
Sir.
Please do that. And get the theta.
Sir, in the second equation, sir, they have written n by 2 into g into L minus L by 2 cos theta. So we can eliminate we can take L by 2 as the reference line, sir, in case 2.
Why you want to confuse everybody here? If you take down the reference line, is the problem wrong? If you take the reference line here, is it wrong? You tell me.
Yes.
Then why do you want to confuse? Yes, you can take reference line anywhere. That I and you also know. But when in the midst of some solution I am writing here, you want to tell, okay, why don't you take that? As if it is going to be a great advantage in solving this problem. Don't get confused and don't confuse me, please. Aram. Okay. So this L by 2, 4 plus 2, 6. A weak equation.
Sir, I think that in the upper equation, sir, it is mg L minus L by 4 plus theta.
L.
Yes, correct.
L minus L by 4.
This is L minus L by 4 cos theta. Correct. Yes, because this itself is L by 2. No, this itself is L by 2. So this point is L by 2. Thank you. So this should be 4. So if that is 4, I am only taking L, so I can still remove this. Okay, thank you. Okay, we have made all the cancellations here. So on the left hand side, we are left with 3 in the numerator and 16 in the denominator. Okay, so if I take the 4 there, then I'll be left with okay. So left hand side, I'll be left with 4. So that 4. So then 3.4 I'll be left with, and here I'll be left with 4 minus cos theta. So if I push the theta here and show here, I get cos theta is equal to 4 minus 3 by 4.
So that only 3 by 16, so that is addition. So
3 by 16.
3 by 8 plus.
Oh, sorry. Big equation on the board. Correct. Thank you. So it will not be 3 by 16. Thank you. So that 8 is here and here 2, 1 by 2. Sorry, yeah, thank you. So this will be 1 by 2 here. Everything else will go here. Plus will be 3 by 8. Okay. And this will be equal to 1 minus cos theta by 4. Okay, correct?
Yes.
So I will multiply and divide by 4 here. So I will multiply 4 by and multiply this and divide by 4. So I get here 4 by 8. Okay. So this side it will become 4 by 8. So 4 by 8 plus 3 by 8 will be 7 by 8. And I have to just transfer this side. That's equal to 1 minus theta by 4. So this side I transfer here. That's here 1 minus 7 by 8. I will get 1 by 8. So cos theta by 4 I will get 1 by 8. So cos theta will be equal to 1 by 2. So theta will be equal to 6. Okay, we have this option. Correct. Did you also get this?
Yes, yes.
Yeah, because for me, slanting and working, sometimes, I miss out the things. But anyway, fair enough. We got 60 degrees. Shall we check the answer? Hello?
Yes.
All of you got confident? The answer is right? Which is the 55th problem? C is the option. Yes, sir. We got it. See, it is a teamwork. We all did it together. Fantastic. I hope all of you got the idea. It's a good problem. Hello?
Yes, sir.
Just enjoy this. Just see, I want all of you to enjoy solving these problems. Okay, not under duress. I want to crack IIT, I want to crack NEET. Okay, all those things will happen. Forget that. That examinations will come long way. Right now, yes, you have jalebi in your hand, you have to enjoy jalebi. That's it. You have this problem, you have to enjoy. That is how life has to be there. Okay, done. Shall I proceed, students?
Yes.
So, last problem I will be solving, right?
Sir, it is 8:38.
8:38. Wait, you have to give me time because the last problem so that I can complete this topic. 5 minutes. Only 5 minutes will be.
Okay.
Then I can start the next chapter in the next class. Anyway, thank you for reminding. Okay, please solve this problem quickly. There is a rod of length L, the velocity is at the two ends are so and so. What is the distance of the instantaneous axis? This should not take more than 5 seconds to answer. Come on. So first draw the rod.
Yes, sir.
Yes, you have drawn the rod. Right? Okay. Draw the rod. The length of the rod, they have told is L. Okay. And the velocity is at the two ends is V1 and V2. They are asking the distance of the instantaneous. What is instantaneous axis of rotation? How will you find? If you know the theory, it is just this. So draw the velocity vector here and draw the velocity vector V1, V2. Okay, this is what they have told. In opposite directions, normal to the rod at the ends. Isn't it? Yes. And now, what is instantaneous axis of rotation? You should join these two ends. Okay. So this point becomes the instantaneous axis of rotation. Understood? That is, an axis passing through this point perpendicular to the board becomes instantaneous axis. So they are asking you this distance. So you take the similar triangles here. Okay. So it will be V1 upon V2. So if you take this distance as x, this distance will be L minus x. Okay, so this will be x upon L minus x. Okay, just solve for this. Solve for x. That's it. Okay, so better write it ulta. If you write this ulta here, then you will get here L by x minus 1 is equal to V2 upon V1. Okay, so transpose this here. L by x is equal to V1 plus V2, right, divided by V1. Therefore, x will be equal to what?
V1 L by V1 plus 2.
Yes, V1 L by V1 plus 2. Do we have this option? Yes, we have this option. And let me see whether the option is correct. Yes, 56 is C. Done. Okay, friends? Hello.
Yes.
Huh.